Welcome back. This is an Aleks training video on understanding periodic trends in atomic size. So if you have an atom, every time that you go down a new period, you've got a new shell of electrons, and that's making it bigger. Every time that you add a shell, you're adding a new nest of electrons, one outside the next, and so the size of the atom is getting bigger as a result. As you go across the row of a row on the periodic table, you are being pulled in harder and harder. You've got 2 electrons now in the outer shell, or 3 or 4, and so it's acting almost like a stronger magnet, stronger south magnet pulling on the nucleus. You've got more electric charge on the outside pulling it, so it's bringing it in. So your size is going to decrease as you go across a row and decrease as you go up towards the first row. Okay, so that's on a neutral atom. A cation, if you remove an electron, you are going to make it smaller. Okay, so that's the other thing you have to keep in mind. So cations are smaller than anions or neutral atoms. Okay, so if I take a neutral atom and I steal an electron from it, I make that cation smaller. Okay. Conversely, if you add an electron, you're going to make it bigger. Okay, you're either going to go down a new row, like we saw before, where you're going to add an electron and go down a further row and make it bigger that way, or just crowding it by adding extra electrons that don't usually live there. Kind of gets them all crowded, and they're, of course, all negative, trying to get away from each other, and the way that negatives get away from each other is spreading out. So if you were to have an anion is larger than a neutral atom or its cation. Okay, so with those you should be able to figure out this table. Okay, they're asking you to there's 3 here. The first one, chlorine, iodine, fluorine. What are the order of decreasing size? So what is the biggest? What's the next biggest? What's the smallest? Okay. All right. So we've got chlorine is here. All right. Chlorine is here. Okay. And then iodine is here. And fluorine is here. Okay. So which one is the biggest? Well, the iodine will be biggest. Chlorine will be next biggest. Fluorine would be smallest, the smallest. Okay, so this first one is going to be iodine, comma, chlorine, comma, and then fluorine. All right. Your next one is selenium, bromine, and selenium ion. Okay. Okay, so let's see if they're obvious. Selenium, okay, and bromine. Bromine is going to be smaller. And then what's going to happen to the selenium ion? I'm just going to have to make a guess. I don't know. I'm going to say that no, I can make it. No, that's easy. Anions are larger. I thought it was the other way around. This is easy. Selenium is going to be bigger than bromine. And the selenium ion is going to be bigger than selenium, okay, because an anion is larger than the neutral atom. So that means that I'm going to have selenium 2-, that's the ion, and then selenium atom, and then bromine is last. Okay. And now your third one, magnesium, magnesium ion, and sodium. Okay, so magnesium is here, sodium is here. So magnesium is smaller, sodium is smaller. Okay. Here's the one that I was thinking it was that I'm just going to make a guess. Magnesium is smaller than sodium. That's easy because it's towards the right. Magnesium is going to be the biggest because your magnesium cation is going to be smaller. I'm not sure which smaller. I would be making a guess here. It'll be sodium is the biggest. Okay. No, this is easy again. I don't know what I'm talking about. Okay. Sodium is the biggest, magnesium is the smallest, and then make a magnesium ion is even smaller than that. Yeah, that's easy. This is easy. So this is going to be sodium, magnesium normal, magnesium, and then magnesium ion. Okay. Thank you very much.